Hello everyone, welcome to the second tutorial in the sorting methods. Today we're going to look at bubble sort, and it's another sort that uses a method of pushing numbers one at a time across an array, but it tries to push the highest number towards the back of the array and keeps doing that and iterates around in a circle until all the numbers are pushed back. It still ends up with the smallest number being at the front and the longest number being at the back. It just does it in a slightly different way. If you haven't watched the first video, I strongly recommend you watch the first video, as it does the setup of all the files and the controls, and it does our first insertion sort method. Now we're going to be continuing on with our program that we're using from the first tutorial, so if you haven't done that yet, go back and have a look at it now. Alright, so at the moment we've got our main sketch. We're not going to change anything there. We have our control sketch, which has our mouse press left and right. One being left being our randomizing our values in our array, and the right mouse click being the sorting algorithm. At the moment we have insertion sorting on. We are going to put a double line, double backslash on that, so that it actually doesn't run that line of code. And if we run this, and I think I've got 10,000 lines of code, so let's not run this. Let's just check our number. We've got 1,000,000. Let's go back to 1,000 just to begin with. Make sure your numbers array is set to 1,000 so we don't crash our program straight away. Should pop up when we left click. There we go, there's 1,000 numbers. If we right click on our program, yet again, it shows 1,000 numbers still in that randomized order. Doesn't give us anything extra. Alright, that's no good. We need bubble sort. So we're going to create a new tab, and we're going to call this bubble. Everyone loves bubbles. Maybe not. I don't know. Alright, so we are going to create another function, void. We don't have to return anything. Bubble sort. And opening closing brackets and opening closing squiggly brackets. Control T, make it nice and neat. Alright, let's put a space in there. So what we're going to do is we're going to have it iterate through itself twice in a row. So to do that we need two for loops. One's the first pass and one's the second pass. And then inside that second pass we're going to do a test to see if the number is greater than the number next to it, and if they are, swap them over. So if the number on the left is greater than the number on the right, swaps them over, and it keeps swapping that number until it gets to the back of the array or it reaches a number that's greater than it, and then it will run through it again with the next number and again and again and again. So it runs through all the numbers, pushing them all towards the back, hopefully getting an array that is sorted. So to run through all our numbers in an array, we're going to use our for loop again, and we're going to set up let's use I to just random character. You can pick any random character you like, just not a number. Alright, and we're going to go I is less than size. Just remember, size is our big array is -1. Why are we doing -1? Ooh, well, we don't want to look at the last piece of our array, because if we look at our last piece, then we're trying to look at the one right of it, which means it's going past the end of our array. Our program crashes and doesn't work. So that's why we're not going all the way to the end of our array. We're actually going to the second last piece, because it will check against the last piece, and that way we don't actually have to look at it at all. Alright, so that's our first pass. Now we need our second pass that is looking at our number again, and we're actually shortening the size of the array by the size of the first pass. So we don't have to go through the pass 100% all the way through again every single time we do this test. So we're going to put another for loop in, and we're going to call that J, just as another random letter. And we're going to go J is less than size, because we can't have it bigger than the size, minus I. So this is what's reducing it. And we still can't check for the last number. That's why we do -1 again. So we still don't want to be checking for that last number in our array, because if I 0, size -0 is still the size, so it still will cap out and hit 99. We don't want it to hit 99, we want it to hit 98 because we're going to check against 99, or in this case 999 because we've got 1,000 elements at the moment in our array, and we're going to increment that up as well. So there are 2 passes, and there's going to be a few little brackets, so just check your brackets, Control T, make sure they all line up. So I've got my set on the outside here, set here for the for loop, and set here. Now inside this last one, this is where we're going to do our test. We're going to test our J number, and we're going to go if numbers, because that's the name of our array, J, we're getting the J position, is greater than, and we're checking against the one on the right, so the one position above it, numbers J plus 1, and that's going to be what we're looking at. We're going to look at this and see what happens. Now, if this is true, squiggly brackets, if this is true, we want to swap them over. So we're going to create a random, just a really temporary temp. I'm even going to call it temp because it's a temporary integer, and we're going to put J in there. What is the value of J? Doesn't matter what the value of J is, that's what we're going to stick in there. Ooh, numbers. Let's make sure we spell that correctly. All right, now we're going to swap them around a bit. So numbers dot J is now going to be equal to that number that was bigger than it, which was J plus 1. So numbers J plus 1, and that J's just changed. But we still have the value of J in temp. Temp, it's still here. It's still here for us. We've just changed this J to being whatever J1 had in it. Oh, we've lost J. No, we haven't. We put it up in temp, and we're going to use it. And now we're going to set numbers, and it doesn't matter what J is, J plus 1, so the position above J, equal to temp, because we need that number back. Ooh, I can't spell numbers again. Make sure you spell numbers. Maybe I should have just called it number. Make it a little bit easier. Guess what? That's all this bubble sort is. It just does this check. It loops through everything. Inside itself, it loops through it again. And it keeps doing that. And it goes all the way through all those 4 loops. So it does double the amount. Slowly getting smaller. That inner one gets smaller. But the outer one stays the same size. It does the whole array. So that's a bit ineffective. But this is all you need for bubble sort to work. Alright, so let's have a little look. Let's copy bubble sort. Let's go to our controls. So we turned off in selection sort. Insertion sort. Whoops, selection sort's a little bit different. It's something else. Let's not talk about that one yet. Alright, so we're going to put bubble sort in there. See how I've still got it in between my before and after? That's where we want it. Alright, let's run this piece of code. How many we've got 1,000 numbers, so when we click left click, oh, there's our populating 1,000 numbers. That's beautiful. And right click, bang, it does it. It took 7 milliseconds, so that's like a 7,000th of a second. That's pretty quick, very quick. We're at 1,000. All right, let's go 10,000. Run it again, click. All right, loads up 10,000 numbers for us. Right click. Oh, that took 108 milliseconds. So that's, what's that? Like 1/10 of a second. 1/10 of a second. All right, we're going to do it again. Oh, let's go 100,000. See what happens. Left click. Right click. Ooh. Uh-oh. What have we done? It's crashing it. It's crashing. Struggling. Oh, it did do it. It did do it. But it took 11,528 seconds, milliseconds, which is 11.5 seconds to do that calculation. 11.5 seconds. That's not very effective. If we put it at 1,000,000, I'm not going to put it at 1,000,000. It just break the program, just like it did before when we did insertion sorting. It'll just crash. It won't actually probably run at all. Now, it's not very optimized. It's not very good. Bubble sort, it looks very, very simple, but it's not that great when we think about it. It can only do, what, 10,000? Maybe we can do 50,000 if we put it at 50,000. Try 50,000 out, see what happens. don't think it'll quite be good enough. Alright, but we can optimize it a bit. See, inside here, if we don't actually have to make a change, then what was the point in doing it? So only if when we iterate through and that we actually have to make a change. If we don't have to make a change through a whole pass, the whole second pass, which is this second if statement, if this comes out that we didn't actually make a single change, then our array's sorted. That's actually that's what it means. And we can actually add just a couple of little bits of code in here to make it a little bit more faster, so it doesn't have to go through this big long loop at the top here, which never changes size. I've got 10,000 items, it's going to have to iterate 10,000 times no matter what. So that's not very good. -1. Okay, -1. We got our size -1 here. But that's not very good. Alright, so we're going to just add a tiny little bit of code. Tiny little bit of code. So above our top for loop, we're going to go Boolean, which is a true or false statement. And we're going to call it swap. Swapped is equal to false. Alright, so now we're going to use swapped. It comes up with this message saying we haven't used swapped. Well, we're just about to use swapped. And what we're going to say is if in our if statement, we actually do swap numbers. So if this if statement happens, if this is true, then all this runs, and that means the swap has occurred. So swap is equal to true. There we go. Swapped is equal to true. Now, if a swap occurs, we've got to keep going. If a swap hasn't occurred, we don't actually have to keep going. And this is the tricky part. You can't put it inside the first, the middle, the inner for loop. We can't put it in here. We actually got to put it here, in between this one and this one. Because you can see they highlight in between the two. And we're trying to put it in between the two of them, so that when we get out of that inner loop and no swaps have occurred, we can say, it's done. We don't have to go through the big loop again. We don't need that. So we're going to go if swapped is equal to false. Just remember, equivalent to, not equal to. And we're going to write some code in here. And we're going to use a special little function. It's called break. What break does, it actually bumps us out of the loop that we're in. And the loop that we're in is this one, because we're outside of this loop, we're actually in this loop, and it'll bump us out of that loop. And when we bump out of that loop, the function's complete. It's over. It doesn't have to do anything else. Alright, so we're going to run this, see what happens. We left click, and then we right click. It's still going to take a bit of time. It's still going to take a little bit of time. Just remember, it took, what was it? 11 seconds for this program to solve this. Alright, so it took 12 seconds that time. So it wasn't a very good one to test it on because it didn't quite make it faster. Alright, so we're going to run it again. Left click, and this won't always help it. Right clicking, seeing what happens. Is it going to help us? No, still didn't really help us with that. So it actually does help, but only in certain situations where the list of information you're trying to sort is actually partially sorted already. If it's completely randomized, this is not going to help. When you have different sets of data where maybe you've only got a couple out of order, this will help a lot. So if we had a very closely sorted array and we just had a little bit left, or we know we added a couple of bits and pieces or just changed a couple of bits of information, bubble sort is actually quite quick at doing that, because it just goes oh, I don't need to do it anymore, and it just stops. But in this case, because they're completely randomized, it didn't help our piece of code. It's good to have that bit of code in there, so when you're doing other things like adding scores onto, say, a table of high scores, and you just want to sort that very quickly, bubble sort will do that really quickly. But when you're crunching numbers that are completely randomized, it's not going to help it. It's not going to help. Alright, but that's bubble sort in a nutshell. in a nutshell, sorry. Alright, so bubble sort, very short, very powerful, but still yet again we only got to, what were we at? 100,000, and well, if I did it at 1 million, it'd take like 2 minutes to do. So it's just not that effective yet. Alright, that's where we're going to leave this tutorial. So this was bubble sort. The next one we will be looking at is quick sort. And guess what? What the name says, it does. It's very fast. Alright, until then.